another example of average value, x over x squared plus 1 over the interval from 0 to 3. All right, so just recall that the average value is 1 over b minus a integral from a to b of our function with respect to x integral. So in this case, it's going to be 1 over 3 minus 0, integral from 0 to 3, x over x squared plus 1 dx. To be able to evaluate this, we could use a number of methods. Probably the easiest one is going to be a u sum. So let's let u be equal to x squared plus 1. That means that the derivative du is going to be 2x dx, which is pretty close, all right? But unfortunately, not exactly what we want. So we're just going to divide by 2 to get our x dx, all right? So x dx is going to be our du over 2. X squared plus 1 is going to be u, and we still have the 1/3 out front. So this is going to be 1/3 integral from a to b of du over 2 over u. Right? Now, du over 2, we could just factor out a 1/2, and we could write this as 1/6 integral from a to b du over u, or 1/6 natural log absolute of u from a to b. And then remember, u was x squared plus 1, and a and b were 0 and 3. So ln of x squared plus 1 from 0 to 3. Okay. And so finally, we can just substitute 3 and 0 back in. So we get 1/6 ln of 3 squared plus 1 minus 1/6 ln 0 squared plus 1. This just turns into ln of 1, which is just 0. So that goes away. And then we get 1/6 ln of 9. All right. Now, I don't know what 1/6 ln of 9 is, but we could certainly use Wolfram alpha. All right. So let's just type that in. So 1/6 times ln of 9. All right. And that gives us a value of 0.3662. Okay. So, and the reason we want that is because that way we can estimate the graph. Okay. So that's approximately 0.3662. Right. But this is the number we really want, the precise value. We're going to graph both the function as well as the average value on the same graph. Okay, so I'm going to go to foo plot. And foo plot, when I graphed x over x squared plus 1 from 0 to 3, it looks like this. I did have to change the y value a little bit. And remember, we got the value 1/6 times ln of 9. Now let's see if foo plot likes that, which it does. All right, remember that was like 0.3662 or something like that. So this is the graph of the average value. Okay, and if I were to graph this on our page here, we get something like this. Okay, it's not going to be great. All right, but I think that's about it. Okay, actually that might be a lot better than I thought. And then right about here is going to be f bar, okay? And remember that was 1/6 ln of 9, okay? And remember, this can help us to find the area bound by the function, okay? So hopefully that helps you to see another example of this. One more example is that we have x ln x over the interval from 0 to e, right? So this time we have a transcendental sort, not an algebraic, but no big deal. So we're going to set this up. 1 over e minus 1 integral from 1 to e x ln x dx. All right. Now, unfortunately for us to be able to evaluate this integral, we're going to have to use integration by parts. And remember our formula, uv minus integral v du. All right. So we're going to start by defining u and dv. All right. In this case, u has to be the natural log of x because we don't know a basic antiderivative. Okay, so dv is going to be x. That's a little bit contradictory from what we're used to, but it is what it is. Now we know the derivative is just going to be 1 over x dx, and the antiderivative is going to be x squared over 2. And we're just going to substitute back into our formula. Remember, uv v du. Okay, so this is going to be equal to 1 over e minus 1. And then we have our uv, which is going to be x squared over 2 ln x minus the integral of v du. So that's going to be x squared over 2 times 1 over x dx. All right. Now this is from 1 to e, and this also is from 1 to e as well, since we evaluated. Some good news, we can go ahead and simplify this fraction, right? And if we do so, we're going to end up with 1 over e minus 1, x squared over 2 ln x, minus the integral of from 1 to e, and this is also from 1 to e, of x over 2 dx. All right, so we're getting there, okay? Getting closer. And so finally, this is going to be 1 over e minus 1, x squared over 2 ln x, minus x squared over 2 times 2 from 1 to e. All right, or another way we could write that is just 4. Okay, so just making sure everybody understands where we're getting these values from. All right, and so this actually is going to turn into something a lot nicer than what it looks like at this point. So 1 over e minus 1, we're going to substitute e, so we get e squared over 2 ln e minus e squared over 4. And then I'm going to substitute 1. All right, so that's going to be 1 squared over 2 ln 1 minus 1 squared over 4. All right, so let's play good news. All right, the ln's are really nice because remember, ln of 1 is 0, so that just goes away. ln of e is 1. All right, so realistically, we're going to end up with 1 over e minus 1, e squared over 2 minus e squared over 4 minus 1 over e minus 1 times negative 1/4. All right. We know that this is going to turn into e squared over 4 if we get a common denominator. So I think you can clearly see that this is going to turn into 4 or 2 over 4 if we get a common denominator. And we have 2e squared minus 1e squared, which is 1e squared. And we could factor out this 1 over e minus 1. So one possible answer that we can get is going to be 1 over e squared minus 1, e squared over 4 plus 1/4. Okay, so negative times negative. Okay. Or in a really compact form, if we wanted to write this, we could write this as e squared plus 1 over 4e minus 1. All right, and that's probably the best that we can get with this. All right, now let's go ahead and make sure that this matches up to the graph of what the average value looks like. Okay, so I'm going to go back to Wolfram Alpha. Remember, our function was x ln of x. Okay, and maybe x times ln of x. And I also have to get rid of this average value. Okay, and remember our domain. I'll get rid of this as well. Our domain was from, I think it was from E1 to E. So x is 1. And this is exp of 1. All right. And then we can resize the y. All right. So that didn't really help too much, but we'll skate out just a little bit. That kind of botched that, but that's okay. Actually, that doesn't look too bad. All right. So we don't need any negative values. So let's go from 0 to, let's say 5 and see what we get out of that. Okay, so that's not too bad, right? Now remember, the average value was this ugly guy right here, e squared plus 1. So that's going to be exp of 1 square. So that's going to be e squared plus 1. Right? Then we're going to divide that by 4 times the quantity of e. And I think it was plus 1 as well. Let me verify that. E squared minus 1 or e minus 1. Okay. So, all right. So let's see what we get out of this. On parentheses. Okay. Okay. All right. So here's our average value. Okay. Which looks like it makes sense because it's almost right in the middle of this graph. Okay, so if I were to scroll out just a little bit to get to the origin, all right, it looks like certainly we have some negative numbers. And if we add up those negatives with the positives, and then over here, these are substantially larger, well, not substantially, but larger. but it's kind of offset by these negative values. All right, so if I were to graph this, okay, remember we're only going from 1, all right? So this is going to be our graph. Okay, remember that crosses the axis at 1. It's going to do something like this, all right? And then we get this as our average value. So that's our F bar, and this is going to be our F bar value. Okay, so hopefully that helps you to give you a couple more examples of being able to work with the average value of a function. We do have one last example, which we'll show in another video.